Time travel. The concept of journeying through time has fascinated humankind for centuries. From science fiction novels to blockbuster movies, we've imagined ways to move freely through time. But could it ever be possible? Let's dive into the science behind time travel and explore if it's more than just fantasy. Time travel has been a central theme in fiction, with stories like H.G. Wells' The Time Machine sparking our imaginations. But behind the fictional narratives, there are real scientific theories that suggest time travel might not be as far-fetched as it seems. Let's take a look at the science behind it. In 1905, Albert Einstein shook up our understanding of the universe with his theory of special relativity. It fundamentally changed how we view space and time, proposing that time isn't fixed, it's relative. What does that mean for time travel? Special relativity tells us that time slows down for objects moving at very high speeds, close to the speed of light. This phenomenon is known as time dilation. For example, imagine an astronaut travels to a distant star at near light speed. While years pass for people on Earth, the astronaut would only experience a few months. When they return, they would have traveled to the future, experiencing time travel, but only forward. In real life, time dilation has been observed in experiments with atomic clocks on satellites. These clocks tick slightly slower than those on Earth, due to their speed and distance from the planet. So, in a sense, we've already traveled to the future. But how about going to the past? Now, time travel to the past is a whole different challenge. To even imagine going back in time, we need to delve into Einstein's general theory of relativity, which deals with how gravity affects space-time. According to general relativity, massive objects like stars and black holes can warp space-time, creating paths that might loop back on themselves. These theoretical paths are called closed time-like curves, or CTCs. One idea for time travel to the past involves wormholes, hypothetical tunnels through space-time that could connect distant points in time and space. Imagine a wormhole opening up in space, allowing you to travel through it, emerging not just in a distant part of the universe, but in a different time, either the past or the future. However, there's a big catch. In order to create a wormhole, scientists believe we'd need something called exotic matter that has negative energy. So far, we've never observed this kind of matter, making it extremely speculative. Now, even if we could figure out how to build a wormhole, there's a major issue: the grandfather paradox. If you travel back in time and prevent your grandfather from meeting your grandmother, you could erase your own existence, creating a logical contradiction. How can you exist if you were never born? Physicists have proposed various solutions to this, like the Novikov self-consistency principle, which suggests that events will adjust themselves to avoid paradoxes. In other words, even if you tried to change the past, something would prevent it, ensuring consistency in the timeline. Another intriguing idea comes from quantum mechanics, which suggests that the universe exists in a state of constant possibility. Some scientists speculate that time travel to the past might not cause paradoxes, because traveling back could create an entirely new timeline, like opening a new branch of the universe. This idea ties into the multiverse theory, where multiple timelines coexist in parallel. While time travel remains purely theoretical today, the exploration of these concepts is not just a matter of science fiction. It's pushing the boundaries of physics, technology, and our understanding of the universe. If we ever figure out how to manipulate space-time, we could unlock unimaginable possibilities. In the near future, we might see technology that allows us to explore the far future through time dilation, as we send humans to distant stars at relativistic speeds. But true time travel, back to the past or forward in ways we can control, is still far from achievable. Scientists continue to study the fabric of space-time, looking for new insights into time, space, and how they might be manipulated. As our understanding of the universe grows, who knows what might be possible 100 or 1,000 years from now. Time travel may remain a mystery for now, but the journey to understand it is an exciting one. From the physics of relativity to the mind-bending possibilities of quantum mechanics, our exploration of time is just beginning. Subscribe to our channel for more fascinating insights into science, space, and the unknown. Who knows? Maybe one day, you'll be the one traveling through time.